Sometimes, Jonah, it's just a little too easy. Have you started on
Were you up until midnight grading tests?
I thought, oh, this will just take an hour or two. It's like I was a complete idiot. No, I was up till, stayed all the way till 6 o'clock yesterday, and then I gave up and came in this morning and finished it. So I didn't get everything out last night. Now you guys should have midterm grades. I did put those in. Anyone see that? Do you get a notification when those come in?
I don't think so.
Does anyone actually ever look at their midterm grades sometimes?
Some of them don't mean much, like days in and out. No tests, a couple,
Well,
which is 10% of your grades.
yeah, that's why I wanted to try to get the test done before the limit. I'm now thinking maybe I should just not worry about it and do the test a week later than I did, because I worry you guys didn't have enough time to calmly consider Lagrangians, but.
The Lagrangians weren't the bad part of the test.
Yeah, that's kind of what surprised me. I kind of thought Lagrangians were going to trip people up. Yeah.
Oh, yeah.
Yeah, the oscillators were pretty brutal.
All
All right, whatever. Go ahead and grab food, and we'll get started.
Numbers, and then just skip 15 steps right up there to the, the limit of
That
this,
huh?
for that, and then skip all the steps of the derivative, strictly answer some number, write that down with test. What you do on the
I word the test on the whole.
Don't worry, I can take it. We're gonna get this acceptable, right? I did that for the second. Did you do the second question?
6 older siblings, Joe.
It was
I
like,
think I can take
prove
it.
this equals this. I wrote on like,
Siblings.
I factored it out, or expanded it,
Yeah.
I just wrote combined like terms.
I have 7
Let the
siblings.
answer full credit. It's like, what?
I think I could take anything you could dish.
So before I give you the exam, let me tell you what the big picture was. The mean was 63 and the standard deviation was 19. So this is good for me. Actually, the lowest score was a 25. And the highest score was, somewhere around there. So what I try to do in an exam, and please don't be offended, my exams are not supposed to make you feel good about how you know everything, okay? For me, the exam is a diagnostic tool designed to test what you know and what you do not know. And therefore, I'm very pleased with this, because there's a nice wide spread of grades, and that's what I was looking for. So, your low numbers are a source of amusement to me. I just want you to know that I think this is a success. Roughly, what this means is that greater than, if you got at the average or above, that's pretty much an A, actually, around here. You got one standard deviation below, so that's roughly a B. And then if you did worse than that, this is roughly a C. If you took the test, no one got worse than a C, as you can tell, okay? So that's, the numbers are not meaningful in and of themselves, so please do not become concerned if you have numbers that would be considered, borderline failing in some bogus humanities class. And here, you get an A out of that, okay? That's physics, kind of in a nutshell. Yeah, if the average is too much higher than a 50, I feel like I've kind of failed, so. I did not fail.
You didn't spend enough time writing that test.
Well, I mean, it is difficult for me to gauge, and I frequently screw this up, like badly. How many problems I should have, how difficult the problem should be, stuff like that.
Everybody got like an 83.
What's the time? How was the time? Did people think? Who thought it was too short?
Like
me!
3 minutes
Like a
too
couple
short.
minutes, maybe.
So,
Is that reasonable to say?
so meaning that you wish you had a couple minutes more. Okay, so it was a little on the long side then. Okay.
It was just like, okay, here you go. Instead of like.
I'm trying to figure out which Brian you are. Wait, don't tell me.
Whichever last name doesn't make you think of a beard, right?
Carter?
Mhm.
Okay.
I was really hoping for more points on the question I didn't even answer.
Alright.
Dang it.
I was very generous, I thought.
Wait, he didn't give any partial credit for nothing?
I know.
What? That's about, I mean, no, I mean, if you actually just completely wrote down something completely out of your butt, I didn't write down anything. But if it was like vaguely related, you got at least some credit for that. So it actually, I didn't think it was so bad. Okay, is that everybody here? Okay.
Good job.
All right, so,
I felt really good about it.
what I thought what we do is we just basically, we'll just do the test right here, and this will be the solution set. We'll just do the whole thing on the board, and see how it goes. And then ask questions or help me out as we go, and we'll just play it by ear. Is that okay? So if you have questions, we'll get to them as we go through. Okay. So problem 1. Write down the Lagrangian for a cylinder that rolls without slipping straight down an inclined plane, which is at an angle alpha from the horizontal. Okay, so I don't know what you guys do, but I always draw a picture. Maybe it's because I'm an observational astronomer, so if I can't put it in a picture, it doesn't exist. All right, so we've got an inclined plane, angle alpha. We have, what was it, a cylinder? Okay, cylinder. It's rolling down without slipping. Mass M, radius R. Okay. All right, so the first question is, what's the Lagrangian for that? Okay, and remember, this is, I guess I didn't specify it on this problem, but I should have. Let me write down that I do that in the future. All right. What I was looking for here was the first step of the that I specified in terms of the rules in the recipe for going through, which is to write down the Lagrangian in some inertial space. So I think a main problem people had here was they got too fancy trying to figure out. Do not get fancy here. Just keep it basic. What are the kinetic energies you have to worry about?
The translation.
Right. There's 2. Translational, so that's just 1/2 mv squared. I don't care what the v is or the units are there. Don't worry about that yet. Plus 1/2 I omega squared. Fine. Okay. And then, are there any potential energies we have to worry about?
Yeah, the high zero gravitational.
MGH. Okay, so really all I was looking for on this one is this, 1/2 mv squared plus 1/2 I omega squared minus MGH. That's 10 points on the first one. Okay. And as you can see by the fact that I said if you included all of the kinetic energy, last time I taught this course I asked a similar question for which people did not get that part. So I was trying to convey to you that you need to include the 2 different kinds of kinetic energy, but most people did that fine this time, so that wasn't an issue for the most part. Okay, so the next question, any questions about that part? That part's pretty basic. I mean, it's basic if, like me, you know what the answer is, or you know what I want. That is actually the hardest part about writing exam questions, is to translate what you're thinking into something that will be easily interpreted by an undergraduate, which we sometimes fall down. Yeah, please get food while we're going, because eat it while it's hot. There's no reason to wait. Okay. So part B was going to be to now convert this into a generalized coordinate. And I'm enforcing that there's only one allowed generalized coordinate, and that is this is the distance down the plane. Wait, don't tell me. Are you Bryce? Okay. All right. getting better. I think I got everyone in this room. I'm very pleased with me. Of course, sort of by definition, the ones that aren't here are the ones I have trouble with. So I don't see their faces often enough. Okay, so now we just need to convert this into this generalized coordinate x headed down the plane, all right? So what do we need to convert? Well, we have a v, we have I and omega, and then we have an h that we have to figure out. Let's start with the h because I think it's going to be easiest. All right. What's h in the generalized coordinates? So what's is a function of x?
X sine alpha.
Close.
Minus x.
I think it's minus x sine alpha, right? So the 0 point's arbitrary. We'll just set the 0 point to be where it starts. And it's only going down from there in terms of height. So it always needs to be negative.
But your x is defined as slightly down, isn't it?
Yes. It's down the plane. So let's look at this. Let's think about this. So say you have some distance x down the plane, and this is the angle alpha. What you want to know is h, which is this value over here. Right? So sine is opposite over hypotenuse, right? So it's h over x. So that distance is h, and it's just in the negative direction because you're heading down. Alternately, you could define this height as h naught or something and call this h naught minus x sine alpha. That's fine. It's a constant, it won't affect anything. Okay, this is the next easiest. What's v as a function of h? Sorry, v is a function of x.
X dot.
X dot, yep. Maybe that one was easier than the first one. Take it back. Okay, what's I, the moment of inertia? I think I even told you this, right? Yeah, it's 1/2 mr squared, so that's done. Okay. So all that's left is the hard part. What is omega? Right. How do you know that?
Because x dot equals r omega.
Right. So you have a rotating. See, I didn't think this problem was that hard. So here's the radius. It's rotating with angular velocity omega. So the velocity at which the outer part of the cylinder is rotating is equal to, so this is v outer or whatever, and that's equal to r times omega. Does that have the right units? Meters per second, so yes, or distance over time. And of course, rolls without slipping is telling you that this v outer is equal to x dot. So that's equal to x dot, in which case you solve for omega. Omega is equal to x dot over r. Does that have the right units? Meters per second divided by meters should be radians per second. Good, okay. Omega is equal to x dot over r. Okay, now, just have to plug that back into the Lagrangian. That's 1/2 m x dot squared plus 1/2 I, 1/2 mr squared, omega squared, which is x dot squared over r squared, minus mgh, which is minus x sine alpha. 1/2 m x dot squared plus 1/4 m x dot squared plus m g x sine alpha. So total Lagrangian then is then 3/4 m x dot squared plus m g x sine alpha. So that's part B. Then part C, I asked for the Euler-Lagrange equation here so we could get the equation of motion and solve it for x double dot. What's the Euler-Lagrange equation to use?
dl dx equals d dt dl dx dot partial.
Yep. Okay. dl dx, well, that's boring. So that's going to be mg sine alpha. Yeah? That's not hard. Equals d by dt of dl dx dot, that's going to be 2 times 3/4, so 3/2 m x dot. The mass is neither changing as a function of time, and it's on both sides of the equation, so I'll just get rid of it. So this becomes d by dt of x dot, which is just, let me do it again, another line here, so as not to get too fancy. 3/2 x double dot. So what I wanted was the acceleration down the plane, and that's x double dot is equal to 2/3 g sine alpha. Does that make sense? First of all, are the units right? It should be an acceleration in space, so it should be comes out in meters per second squared, and all the units are in the g, so that's right. Is it going down at a reasonable rate? First of all, the acceleration in the absence of rotational motion, if it were just slipping, would be g sine alpha, and it's less than that. Good. Okay. If it were greater than that, that would be bad. It's positive. It's accelerating down. That's good. If alpha is 0, then it's flat, and that should be 0, and it should not accelerate at all. That's right. If alpha is 90 degrees, then it just rotates down at 2/3 g. Huh. Okay. Interesting. So if you had like a Velcro on the side or something that was somehow magic, frictionless Velcro.
We had a more problem like that with the yo-yo. Makes sense.
That I assigned?
Yeah.
Yeah, that I forgot about. Yeah, okay. Yeah, good. And it came out 2/3 G? Good. Well, I'm probably going to grade that as homework, tomorrow. And then I'll learn that part. There you go. Any questions about this first problem? Okay. Well, let's go on to the one that was perhaps a mistake, though I actually was fine with how it turned out and how people did on it. This one was like, I thought this was really easy. In fact, well, not really easy, but what's ironic is that I asked this same question, or I have in the past, of my 211 class, right? And they solve it using the Newtonian method. And hopefully they come to the same answer. Otherwise, this whole physics thing doesn't make any sense. But
You ask them the first question, not the second one, right?
correct. Yeah, not the second one. That would be cruel, because I don't know how. This is one of the reasons I like that second problem. I don't know how you'd solve that in Newtonian space. What a nightmare! Like seriously, seriously ugly. Okay, second problem. This one's kind of hard. Yeah, there you go. All right. Consider a pendulum, spring pendulum. Okay, so made of a spring with a mass on the end. So you got a spring. At the end of the spring is some mass m. The equilibrium length of the spring is L. And let the total spring have some height L plus x. It's a function of time. It would be the difference from equilibrium. And then I said the angle here be theta. Okay. All right, so the first question I ask is, what are the Lagrangian of this system in inertial space? So remember, do not get fancy here. T minus u. What are the kinetic energies in the problem?
Going out and
1/2 mv squared. Kinetic energy. We'll figure out v later. Any other kinetic energies in this problem? There could be kinetic energy of the spring,
Yeah.
which I neglected to mention that it's massless. So you don't have to worry about it. I will fix that should I ever ask this problem again. I don't know if I will though, given that. I don't know. I wasn't too upset with it.
Isn't that
Okay.
hard if you did it
You
wrong?
didn't say, you didn't give it.
There's some truth to that, in that if you got parts wrong at the beginning, it really simplifies the parts C and D. But that's okay. We'll stick with it. What's the potential energy here?
You know, potential energy of the spring would be 1/2 kx squared.
1/2 k x squared. Yep. Is that all the kinetic energy? Or the, I'm sorry, is that all the potential energy?
You have gravitational potential energy.
Gravity. Okay, so that's the Lagrangian that I was looking for the first problem. 1/2 mv squared minus 1/2 kx squared minus mgh. Okay, boom. Don't get fancy for the first part. I guess I did not. Maybe I didn't emphasize this enough in class. Is the first part is just really basic. Do not. It's before you've even chosen your generalized coordinates, right? So you don't even care about that yet. It's just whatever. The important part here is to make sure you get all the components. So we have the kinetic energy, the translational kinetic energy here of the spring. We got gravity, or so I have the mass, and then we have the potential of the spring. That's all you need. All right. Part B then asks you to figure that out as a function of x and theta. Yeah.
Yep.
All right. Okay, well, that part's easy. That doesn't change. That's already in terms of x, so that part's already done. 1/2 kx squared. Let's do the height next, because that's going to be the next easiest. What's the height?
I did L plus X times 1 minus X.
Okay. I did that at first too, but I think it's wrong. Here's why.
Oh, apparently yes. So.
No, I mean, here's what I think the difference is. This is true relative to, you're measuring it relative to a point down here,
Right.
okay? But the L plus X times 1 means that that height, 0 point, is changing with time because X is a function of time.
Ah, yeah, it is.
So I think L plus X times minus cosine plus, sorry,
Yeah.
minus L works. Wait a minute.
Well, except at.
Which way are we measuring this? Negative
From the-
cosine. So negative cosine. So plus L. Yeah. So that would work.
Yeah, except you don't even need the plus L because it doesn't matter what your reference point is.
Exactly. Doesn't matter.
It's negative cosine.
You're welcome to leave this in. It will make no difference in the final answer. But ultimately, just negative cosine L plus X. So if you think about that, that's the distance. If you measure this as the 0 point, negative cosine L plus X, and that works out better.
Easier too.
I did the exact same thing the first time through, man. I was like, wait a minute, something's not right here. And I finally figured out what it was.
There were just so
about
many
that,
problems in like homework. It was like one, where we did 1 minus cosine. I was
You're like, oh, 1 minus
bingo,
cosine.
1 minus
Yeah.
cosine.
Ding! Nailed it. Okay. It doesn't cause that, that part makes it harder though because you have an extra x.
Yeah.
So that part did not make it easier on you. Velocity then. How should we do the velocity?
Well,
First of
the
all,
spring you're gonna have an in and out velocity.
Right,
So that's
so-
just gonna be x dot.
There's two different components of velocity, right? There's this component, which is x dot, and then there's a perpendicular component, which is
X theta dot.
no.
Or L plus X. times
L
theta.
plus x theta dot. Okay, so that's the trick. Those are yet another tricky zone. So the total velocity then is square root of x dot squared plus L plus x theta dot squared. So the rest of the Lagrangian then is plus 1/2 m v squared, which is x dot squared plus L plus X squared theta dot squared minus mg h, where h is L plus X minus cosine theta. That's the second problem. Is that what I have? Yep. It always looks that way from the other side. It always makes more sense. Okay. So that's part B. Excessively long line maybe, but it's not that bad. Part C then is the theta component. Is that right?
Yeah.
Okay. So what's the Euler-Lagrange equation we use here?
DLD.
Partial with respect to theta.
DLD theta is equal to
d dt, partial with respect to theta.
DLD theta. No. Okay. All right, DLD theta. No theta's there. No theta's there. Oh, theta there. So that's going to be mg L plus x. Derivative of cosine is minus sine, yeah? All right? Okay. Equals d by dt, we'll deal with that later. dl d theta dot. No theta dots here or here. Like this is the only theta dot, so that's going to be 1/2 m L plus x quantity squared. Derivative of theta dot squared is just 2 theta dot. Okay, here's the tricky part that tripped a lot of people up. Chain rule. You got to product rule
Chain
this.
rule,
Product rule,
yeah.
okay? Because x is a function of time. And so when you take d by dt, there's an x which is a function of time, and a theta dot which is a function of time. That was tricky to trip people up. You only lost like 2 points or something though if you didn't get that. It's not the end of the world. Okay, so that's going to be m times theta dot times the derivative of that, which is going to be 2 L plus x x dot, derivative of x dot. Derivative of what's inside with respect to time. That's x dot. Okay, plus m L plus x quantity squared theta double dot. Okay, that part's it. So the question asked, solve for theta double dot. You can get rid of some L plus x's here.
And some M's.
And, oh yeah, all the m's go. Well, that's not bad. So then you're just left with theta dot double dot is equal to minus g sine theta minus, so I'm going to move this to the other side, 2, yeah, x dot theta dot over L plus x. Journal looks like he disagrees.
Well, I just have a different answer.
I think you may have had a plus here.
Yeah.
I don't think I penalized you for that. I think it should be a minus.
That really just drops the negative sign.
Yeah, because it was like on your previous line, right? So,
Yeah.
or something. So I think it should be a minus. And if anyone
Wow.
can show me where I'm wrong there, let me know. Because ultimately it's like this triple negative, right? Because it comes originally from this negative, and then the L minus U negative, and then the derivative of the cosine makes it a sine.
If you assume theta dot is 0, then, well, I guess that would help. I'm just trying to think.
Yeah, no, if you say theta dot is 0, so you start it with the, without moving, and a small angle approximation such that sine theta equals theta, then it becomes just a pendulum.
Yeah.
And it should be negative because it should be pointed, it should be pulling you back in order to be
Yeah.
negative
Yeah.
equilibrium. So you're right, yeah, good. See, actually this is a good step that you should always think through that I think would help. When you get an answer, does this make sense? You know, the unit's right. Okay, this is in meters per second
Yeah.
divided by meters, which is in radians per second squared. That's right. This is in meters per second squared divided by meters, so that's per second squared. Okay, so that's not on track. We've already verified it in that in the limit where you just have it and you let it go. And so it definitely helps to sort of think through those limits just to make sure you kind of got everything making sense. Okay, part D then just asks for the same thing using the Euler-Lagrange for x. So let's just dl dx is equal to d by dt of dl dx dot. Okay, so dl dx, where's x's? Here's an x, here's an x, here's an x. Oh, that's going to be unfortunate. All right, but this one isn't too bad. Minus kx. Why does that make sense?
Force of the springs.
This is the generalized force, remember. So this is just Hooke's law, right? Spring pulling back. So there had to be one of those somewhere, so that's good. Next we have a plus 1/2 m theta dot squared derivative of L plus x squared with respect to x. So it's just going to be 2 L plus x times 1, right? We'll just leave the rest. Plus,
Cosine theta.
yep, mg cosine theta. Because the L doesn't matter, so this is just an mgx cosine theta. So which one, sorry, which one is this?
That's another like generalized force because it's that part of gravity that's pulling you.
The component pulling you down, pulling you back toward equilibrium. Yep. Yep. In theta. Mhm. Okay.
And then that would be the centripetal force.
Presumably,
It would be m theta dot.
because this is v squared over r essentially, right? Because v is L plus x quantity squared times theta dot squared. So this is v squared over r. So this is a centrifugal term. Yep. Okay, and that's equal to d by dt of derivative with respect to x dot. Well, that's really easy. That's just m x dot. And in fact, since mass is constant, that's just ma. Okay, well at least the right side was easy because the left side kind of stunk. You can divide through by m, make that a k over m. And then that's the answer I was looking for. X double dot is equal to 1/2 plus the 2, that's even going to cancel. So this is just, sorry, theta dot squared L plus x minus k over m times x plus g cosine theta. So in terms of board meters, this actually took less space than number 1. Though, doesn't mean it was necessarily easier, because there are a lot of little tricks, product rule here, making sure you've made sense with the velocity and the height, are kind of the tricky parts. Questions about this problem? Speak now or forever hold your peace. This is your chance. Everyone okay with that? Okay. So those were the Lagrangian problems that I thought were going to be the hard ones. And then there's the easy part. That was not the easy part.
That nobody studied for it comparatively.
Well, I did tell you it was going to be mostly Lagrangians, and I think that part I held to. I thought I said that the next most important thing was going to be harmonic oscillators, but maybe that part, you know,
Yeah, there's just
Lagrange's
there's so much.
so
nicer.
overwhelming. Yeah,
Yeah, there was a lot of stuff to cover in the harmonic oscillators section.
that's true. And so it's hard to maybe know what was important. And I, of course, instead of focusing on something more obvious, focus on something that I thought mattered more and gave you a result that was interesting. Don't you like interesting
You're just
results?
gearing us up for astrophysics.
Yeah, I know.
That's really what you're doing.
I would never do that. Okay. Though
Yeah,
it is
you
being
would.
offered next
Yeah, you
semester.
would.
Please sign up now. Everyone, please register. All right, so this was considering Earth's tidal forcing by the moon as a damped-driven harmonic oscillator. Earth's tidal quality factor Q is 12. Hence, if the moon were magically disapparated, then how many tidal cycles would it take for the amplitude of Earth's tides, presently 1 meter, to die down to 1 centimeter? Okay, so if the moon or the Earth is a harmonic oscillator, what would the equation for, say, the amplitude of the Earth's tide as a function of time, what might that look like?
Negative beta t cosine omega naught t minus delta.
Yeah. Okay. What's the amplitude? The initial amplitude? 1 meter. So this is a question only about, essentially, this part. Wants to know how long it takes this to die down. So, in order to figure out when the amplitude is 0.01 meters, essentially that's going to be 1.0 meters times e to the minus beta t. What's beta?
The damping factor.
Yes, but how is it related to what we have?
It's like
I actually have to look
omega
up.
naught
It's 2
over
pi,
2 beta?
yeah, 2 pi omega naught over q or something.
It's omega naught over 2 beta.
Omega naught over 2 beta.
Okay.
Yeah.
Beta, or saying the same thing, is omega naught over 2q. Right? So in that case, this is equal to, okay, so e to the minus omega naught over 2q times time is equal to 10 to the minus 2. Okay, so I'll take the log, natural log of both sides. What's the natural log of 10 to the minus 2? Minus 4. Because everyone knows e squared is equal to pi squared, also equal to 10. Tricky little astrophysics bit of knowledge there.
Oh,
you know,
goodness.
for you for all you precision people. Okay, so negative omega naught over 2q times t. What did I ask? The number of cycles, not the number of, not the actual time. So I asked for the cycles. So how many cycles is it? Well, q over pi is the number of cycles it takes to diminish by a factor of e, right? So 12 divided by 3 is also 4. So basically 4 times 4 cycles. So number of cycles, 16. I think it came out to 18 when or 17.6 or something when I did it more carefully.
Everything's 4.
No, pi is 3. So it's e. All right. So that was part A. Part B is what's the phase lag delta? What's the lag delta where relative to the forcing? So assume is forcing it has a delta of 0. What's the delta here? What's the equation that you found if you went equation hunting for the phase lag?
Arctan 2 beta omega over omega naught squared minus omega squared.
Okay. And it says assume that delta is relatively small so we can get rid of that arctan business. And assume that tangent of theta is equal to theta. In which case 2 beta is just equal to omega naught over q, yeah? So delta then is equal to omega naught omega over Q that's part B.
If you know where you're going, it's pretty straightforward.
I think I only had pretty much one equation for what the phase lag was, right? But anyway.
Yeah.
You can just take a moment and
That-
at the end of the test go, wait, he said small angle.
That's all. Well, I mean, if you left the tangent, the arc tangent in, that was fine. I didn't catch off of that. This is that thing where I was swinging the extension cord around my head. I don't know. It made an impression on me, but there you go. All right. So this is part B. And part C was to just plug in numbers essentially to that equation. And that's maybe where I broke down because this depends on the beginning one. So I said in the problem that, let's see, so omega naught was equal to 2 pi over omega naught is the natural frequency of the Earth. So that was over 30 hours, right? The forcing frequency is 2 pi over 24 hours. Divided by Q, which is 12, divided by, what's going to happen here, there's going to be a 2 pi squared, a 2 pi squared in the top. It's going to cancel those 2 pi's, they're not going to matter. And this is then 30 squared minus 24 squared in the top. So this becomes the phase delta, which is going to be, so it's 900 minus like 600, so it's like 300 over 30. Oh good, that's 10. 300, okay, 10,
Pi times
sorry,
300.
10. So this is roughly, divided by 12, of course, is 1. So it's roughly 1
Of
over
course.
24. It's going to be like 0.05 or something. Does that sound right? That sounds too small.
Yeah, that's what it is. That's right.
I have I mean,
I got. Why do you have a 12 on the bottom?
because it's cubed.
Well, yeah, okay, you.
Is that, I put
have
that in the wrong place?
yes,
I have
think
it.
you-
I have it on the bottom here. I never
Well,
actually calculated it out.
Things look flipped. Because you have 12 times omega naught times omega, when that's not what you have in your formula up top.
It is. Omega naught is 2 pi over.
Okay, then you should be
time.
dividing by the 1 over 30 squared minus 24 squared, right?
This is
Oh, I see what you did, okay.
this is
yeah.
2 pi squared, 1 over, I think I did make a math forbidden here. No, I think you're right. That is not the same as what I had before.
I came out with negative 0.183.
This looks like I had like 2 over 12. So you said 0.183. Yeah,
Yeah,
that's very similar to what I got. Okay, something like that. So that's in radians, and that's for what the time difference is, which is 0.18 over 2 pi times 24-hour rotation period, which is going to be that's 2 pi 6, of course.
Gonna be 4
That's
times that.
0.03 0.03 times 24, which is 0.75, yeah? So, 3/4 of an hour. The actual answer is, the real answer is the tidal lag is about 2 hours, so. You know, this is not very close, but, I mean, given the uncertainties and the wild approximations involved, you know, could be worse. So, this was the hard part, as it turned out. which I thought was kind of just a plug and chug. You know, an exponential, find this equation and plug in numbers. But I would say that that is the problem that most people struggled with and that had the lowest scores, as it turned out. So, there you go. Questions about the last problem? Okay. What could I have done differently or better about this exam? And how should I change the final as a result? Any comments of what I should have done? What you'd like for me to have done? A little shorter, maybe? I just always have that problem. My exams are always too long. No matter how long I make them, they're too long.
I didn't think
I
that.
thought I was challenged enough, but
Yeah.
like I got thrown for a loop on.
I mean, if you knew the material and knew exactly where you were going, there was plenty of time.
But that's, yeah, if you knew where you were going, that's the real trick, isn't it? But I do like, you know, for open book exams, I don't want to give you too much time. Okay, I'll cop to this. You guys don't remember this part. There was an exam in graduate school where we were supposed to be studying, it was an open book exam, and we were studying the effect of planetary gravity signatures, and there's different ways to calculate, you know, if you fly over a big lava plain of dense lava, the gravity will change slightly. And I slept in for those lectures, and I literally taught myself it from the book on the exam because I had lots of time. So I want to have you guys a little more constrained than that, so that, you know, if you need to remind yourself on the exam, that's fine. But if you need to learn what a Lagrangian is on the exam, I don't want to give you so much time that you can get away with that. On the other hand, I don't think that was the problem. I think for the most part, people got the Lagrangian parts okay. The final exam is probably going to be very similar in terms of, I hope, difficulty level. It's going to be longer, so there'll be more problems. But it's going to be comprehensive. I guarantee you I'll put a Lagrangian problem on there. It will probably not be as involved of a oscillator problem, but I don't know. I haven't written it, so we'll see.
I think the general consensus is we like Lagrangians. So.
Because there's a system, right? If you get the system, the tricky part it was, and I realize now that, yeah, people kind of got tripped up on the first step. And if you forget, you know, to get, I delete all the Lagrangian stuff, but yeah, if you like get the sign of your height wrong in MGH, like it propagates through the whole thing, and you're going to get a funny answer in the end. And one thing I would like to give you more time to do is to be able to realize, oh, my object rolling downhill actually is suddenly flying up to the left at a great speed because the acceleration is negative. There's probably a minus sign I missed somewhere. If I gave you more time, you might be able to track that down. That would be something to use more time for. So there you go. All right, tomorrow morning we're gonna do more orbits. So we'll see you then.
Even more prep work for astrophysics.
That's
yeah,
really what you need to say.
I'll be going back over this stuff for astrophysics. So no, you don't need this for astrophysics. You'll get to see it again on that for astrophysics. It'll be that enjoyable. Isn't there another? 464 is offered this spring too, right? What are the we were just talking about this. Materials and astrophysics. So those are the only two?
411. He said it's 4.
Yeah, 411. I guess I don't count that as an elective, though. I guess it is because it does fulfill those lab requirements. Okay. Well, you know, you don't have a whole lot of options. It's either me or materials. So.
Those really the only two?
Yeah, well, you
Besides like 490 and
and
411.
We were talking about having the.
general, what?
No, that's just a ghost course. We're never going to offer that. I tried to get it removed from the catalog, so I wouldn't throw you guys off, but they didn't want. They wouldn't let me do it. We're going to offer the new biophysics elective.
Oh.
But Marty's on sabbatical in the spring, so just didn't work out. So we'll do it.
Dang it,
Doesn't best
We'll do it again in a while. Huh?
Was best
Plastekas? He's teaching.
I thought he does biophysics.
Yeah, no, he does, and he would be ultimately the one that is going to be teaching the grad course, actually. The problem is that we were just down one instructor, so it was just the puzzle of trying to figure out who fits where. That it became easier, especially since we hadn't offered biophysics yet, to just put it off and offer it for the first time in 2 years. So you guys lose on that one, but there you go. All right, thanks for coming. Hopefully everyone else will catch up to it. Yeah, later on. Thanks. I think the top button.